Hi, this is Mr. Ralphs, and I'm going to be showing you a couple techniques on common factoring. Generally, when you do some common factoring, you just take a look at what the greatest common factor is, and then you can divide that out of the terms that are available, and then you can simplify the expression in that way. So I'm going to take a look here in this first example, and I've got 8x plus 12. I take a look at both of those and I think, okay, well, there's no variable in the second term, there's just a variable in the first term, so I don't really have to worry about any variables. But the one thing I do have to worry about now is just what greatest common factor I can divide out of the 8 and the 12. So I think for a couple seconds, and I realize that it's 4. Now 2, of course, will also divide out of 8 and 12, but I want to divide out the largest common factor. So I'm going to factor out 4, and when I divide 8x by 4, I get 2x, and if I divide 12 by 4, I get 3. Okay, so that's a quick way of doing that. Now, sometimes in the past I've had students who have a little bit of difficulty kind of getting their head around that. So what I want to do is show you a different technique that I just kind of came upon the other day, and I was a little surprised by how well it worked. But so if we take a look at this, and sorry not to pat myself on the back, but I think this actually works fairly well. So I've got 8x plus 12. I do the same kind of thing. I say, well, what's the greatest common factor that I can factor out of 8 and 12, and that's going to be 4. But what I'm going to do is I'm actually going to multiply this 8x plus 12 by 1. So if I multiply this same 8x plus 12 by 1 by using the greatest common factors, I'm going to be multiplying by 4 over 4. And as we know, inside underneath each of these factors, each of these terms, is just 1. I can write these things as fractions with denominator 1. So now when I multiply fractions, I just multiply straight across. But what I'm going to do is I'm going to leave this numerator 4 outside and just multiply in the denominator. So all I've done is just multiplied by 1. But I've sent this denominator inside, and now I just simplify inside. So 8x divided by 4, you just simplify 8 divided by 4, and that gives us 2x, and then 12 divided by 4 gives us 3. And notice how it's the same thing as what we have here, but just been reduced down. It's a couple extra steps, but I think it might be a little bit more comprehensive and a good way to understand this. Let's move on to another example and see if the same thing works. I'll do it the quick way first. I've got 2x squared minus 5x. I take a look at both of these and I see that there is a variable in both terms, and I can factor that variable out. I also take a look at the coefficients, and I realize that there are no factors greater than 1 that can be divided out of both of those, so I don't have to worry about any numerical factor to divide out, but I'll divide out in x, and when I divide 2x squared by x, I get 2x, and when I divide negative 5x by x, I get negative 5. Okay, so what about doing it my other way that I just came about? And again, I'm going to divide find what the greatest common factor is, but I'm going to multiply this 2x squared minus 5x. I'm going to multiply that by 1 using the greatest common factor, which would be x over x. Again, 2x squared as a fraction is 2x squared over 1, and negative 5x as a fraction is 5x, negative 5x over 1. And then I just multiply this denominator into the denominators inside, so I'm left with x from the numerator out here. Inside I've got 2x squared divided by x minus 5x divided by x, and then just simplify inside, so I've got x 2x squared divided by x is just 2x. 5x divided by x is just 5. So we're left with x, quantity, 2x minus 5. Okay, same kind of thing can be done with these next ones. I'm just going to do the new technique right now, just for fun. So I've got 14y cubed plus 21y squared minus 28y. And as I write this out, I'm going to ask, what's the greatest common factor of all of these terms? And well, I see that there's 14, 21, and 28. Each of those are divisible by 7. So I'm going to write 7 over 7, because I know I'm going to multiply through by 1. And then I've got y cubed, y squared, and y. And so I'm going to multiply, and the smallest of those is y, or the largest power that can be divided out of all of them is y to the exponent 1. So I'm going to multiply, and sorry, I'm not going to multiply the whole thing through by 1, I'm going to multiply this expression by 1. But I'm going to be sending in the denominator, so I'm going to get 7y, quantity 14y cubed over 7y, plus 21y squared divided by 7y, minus 28y, y divided by 7y. And now I'm just going to simplify inside the brackets, so I'm left with 7y outside. Then we've got 14 divided by 7 is 2, y cubed divided by y is y squared. 21 divided by 7 is 3, y squared divided by y is y. And 28 divided by 7 is 4, and y divided by y is just 1. Okay, and then just one last example. 9x to the power 4, y to the power 4, plus 12x cubed y squared minus 6x squared y cubed. I'll see what the greatest common denominator is, or sorry, greatest common factor. I see that all of these are divisible by 3. I see I've got x to the power 4, x cubed, x squared, so the largest power of x that I can factor out is x squared. And then I've got y to the power 4, y squared, and y cubed. The largest power of y that can be divided out is y squared. So I'm going to multiply this whole expression by 1, represented by 3x squared y squared over 3x squared y squared. So I've got 9x to the power 4, y to the power 4, plus 12x cubed y squared minus 6 x squared y cubed. Send in the denominator, so we're left with 3x squared y squared on the outside, 9x to the power 4, y to the power 4 over 3x squared y squared, plus 12x cubed y squared over 3x squared y squared, minus 6x squared y cubed over 3x squared y squared. And then just reduce down the fractions on the inside and I get 3x squared y squared on the outside. Divide this, I get 3x squared y squared plus 4x, and those just cancel, and then minus 2y. Sorry about that, I missed that whole bottom row there. So that is how this expression ends up getting factored out using common factors. So it is a little bit more writing. Actually, it's a lot more writing. However, I feel that it could be helpful to you as you kind of wrap your mind around and get used to common factoring. Okay, so that's another option for you. So give it a try if you wish. If you can just see it right away, then you can be left with neat little tidy factors like that. Okay, well, thank you very much for watching, and we'll see you in class.